Good morning, folks. Welcome to my YouTube channel. Thank you so much for your support. Thank you for your subscription. Thank you for liking all my videos. Continue liking all my videos and watch all my videos. Share with your friends and families. Okay, let's cut the chase. This is question 2 and Newton's second law. That's Newton's law. And then you find it in question 2 always in grade 12 question paper 1. Let's cut the chase. Now we have a system here. It says the system here, it says I want the highlighter. It says write down Newton's second law. Newton's second law, guys, you need to understand by heart. Check the exam guideline when it comes to that. Newton's second law, it says when a net force is exerted on an object will accelerate in the direction of the F net, and the F net is directly proportional to the acceleration, and acceleration is inversely proportional to the mass. Right now, it says a block with a mass of 12 kg resting on a rough horizontal table connected by a light intensible string which passes over a frictionless pulley to another block of mass of 7.5 kg. Okay, now they talk about this 12 kg is resting on a horizontal surface with a rough horizontal surface there, and then they say it's resting, guys. It's very important. When it's resting, that means there's no acceleration. Now it says it's attached to this one, so if this is not moving, this one is not moving as well. Now it says the 7.5 block hangs vertically on the diagram. The force and magnitude F, there's a force that is applied here. Remember, guys, this object is pulled at an angle of 30 degrees. Block 30 horizontal to prevent the blocks not moving. This force, guys, is exerted to prevent the block from not moving. So if there was no force, this force was not available, so this system was going to accelerate in this way, because the gravitational force was going to pull this one downwards, and then eventually the system was going to accelerate in this way. But now there's a force that is exerted here for the system not to accelerate. So the system is stationary because of this force. Right, here are the things that are important, guys, here. So the system is not moving, but since it's kept by this force, there will be a frictional force in this direction. We call that as a static frictional force. And then this force that is applied at an angle, it will have its components. Its components there, it will be the Fx and the vertical component there, which is the Fy there. And remember, I said the friction will be in that direction, Fs. Why is the friction in that direction? Because the system, its intended direction, or in its intended motion, was going to be that way if there was no force that is exerted. So this force is exerted to keep it stationary or at rest. So we choose let's choose this direction. Let's choose this direction as positive. Let's choose this direction as positive. This one is positive. That means or let's stick with the normal one. Okay, it's fine like that. Let's choose up left as positive. Up left is positive. Guys, here are the things that you need to understand here. There's a normal force here in this object that is lying on the surface, because it's on top of the surface. All the time when an object is on top of the surface, there will be a normal force. So, and also there's a gravitational force. Gravitational force is always everywhere. And guys, what is important here, you need to understand the normal force here, it's not equal to gravitational force only. It's equal to gravitational force minus the y component. because it's pulled at an angle. Remember, if it was pushed at an angle, the normal force was going to be the gravitational force plus the y component, right? But we are not there. Okay, now these are the forces that are acting here, and of course there's a force that is exerted by 7.5 kg on 12 kg. It's going to be that's the tension force. Now let's look at the forces that are acting on the 7.5 kg. The 7.5 kg, guys, it's very important. There's no friction, there is no normal force here. No friction, no normal force. Always in the object that is hanging, or the object that is suspended, there will be no normal force. So there will be a tension force in that direction, and there will be a gravitational force. Guys, since it's stationary, this object, the tension force and the gravitational force are what? Are equivalent, but in opposite direction. Equivalent but in opposite direction. Even here, the horizontal forces here are equivalent but in opposite direction. So that means the fx minus fx plus fs are equal to what? To tension. So these forces that are horizontal, they are equivalent. They're equivalent, right? Because it's at rest, the acceleration is 0. Even here, they are equal because it's at rest, the acceleration will be 0, the f net will be 0. Okay, guys, now it says now the maximum coefficient static friction, which is mu s, between the 12 kg block and the surface, it's 0.45. Ignore the effect of air friction. So guys, the description of the surface here, which is the mu s, because it's not moving, it's a static frictional force, it's going to be 0.45. It only applies here. Friction only applies there. Okay, guys, I would like to draw the free body diagrams of both because it's very important, even though they are not asked here. I would like to draw them. They are free body diagrams. Okay, let's draw the free body diagram of the 12 kg. 12 kg, it's going to be, let me erase that, make it neat. Erase all the unwanted stuff. Okay, remember we chose this direction. Okay, the free body diagram, the free body diagram here, it will be, let's do the 12 kg here. You see I'm labeling it. Here's the 12 kg. There's a normal force, there's a gravitational force, there's an Fy, vertical component that is going up, and then we have an Fx, and then we have Fk there, and then we have the what? The tension force. That's the 12 kg. The 12 kg. Let's look at the 7.5 kg. 7.5 kg, we have the tension force, and we have the gravitational force only there. It's very important, guys. It's not asked the free body diagrams, but the free body diagrams are very important. Very important. Now 2.2.2, it says calculate the tension of the string. The tension of the string, guys. The tension is very important in the system here. The tension, this tension and this tension is equal. The tension force that is exerted on 12 kg by 7.5 kg is equal with the tension that is exerted by the 12 kg, which is this, on 7.5 kg. So let's use the easy one to get. Let's use that. Let's say 2.2.1. We'll use the 7.5 kg. I'm labeling it, it's very important. We'll say F net is equal to MA. Remember guys, I said here this tension force is equal to the what? To the gravitational force. So calculating the gravitational force, it will give me the tension force there. So since our acceleration is 0 because the object is at what? Is at rest, so this side will be 0. So the forces that are acting here, it's these two. So it's going to be positive tension minus the gravitational force. So this simply means that the tension is equivalent to the gravitational force, right? So T is equal to mg, and then we substitute the mass at 7.5. The 7.5 times 9.8, 7.5 times 9.8, the answer there, it'll be okay, 73.5 newtons. That's the answer there, right? Let's go to 2.2.2. 2.2.2, it says calculate the minimum value F that will prevent the blocks from not moving. So 2.2.2, it wants the force, right? It wants the force. So guys, the force is exerted on this object, on the 12 kg object. So let's use the F net on the 12 kg object. 12 kg, it says F net is equal to MA. Now the acceleration is 0. What are the net force? What are the forces that are acting on 12 kg object? The forces that are there, we have an Fx that is positive, we have an Fs that is positive as well, minus the tension. The tension force is negative because it's going to the left. Where do I get that? Here. Guys, go back to the video why the frictional force, it's positive, it's in the same direction with that. So yeah, rewind the video. That's what I'm trying to say. F cos theta, we're looking for what there? What are we looking for in this question? We're looking for a tension. Do we have a frictional force? No. So we have here the frictional force. Here will be, the frictional force, it will be plus mu k, mu s times the normal force. Guys, remember I've mentioned above, it's going to be Fg, which is mg, minus the Fy, which is F sine theta, right? F sine theta minus T equal to 0. Okay, so we're substituting what we have now. We do not have the force, the angle cos. It's cos what? Cos 30. It's cos 30 plus the mu s, it's 0.45 times our mass there. Our mass is, it's 12 times 9.8 times 9.8 minus F sine 30 degrees minus T is equal to 0. So guys, what are we going to have now? Our answer here, if we punch in a calculator, this guy will have 0.866 F, and then it's very important here, guys, I did not substitute the tension. We do have the tension here, so it's minus 73.5. Where do we get the tension again? We got it here, right? So now what are we going to have? We will say this multiplied by this, right, and multiply by this, right? So our answer here, it's going to be let me punch it in a calculator. So it's going to be 0.45 times 12 times 9.8. So the answer there, it will be positive 52.92. This is the answer where, and then I distribute that, multiply by that. So 0.45 multiplied by f sine 30. Sine 30 is what? Is half. So we'll say 0.45 multiply by sine 30. Sine 30 is half. Sine 30 is half, so it will be half of that. So it will be negative 0.225 f minus 73.5 equal to 0. And then we have the like terms here. This and this are like terms. The answer of it will be, the answer of those like terms, if you say 0.866 minus 0.225, these two, the answer there, it will be 0.64 f. And then the answer between these two, it will be, the answer between these two, okay, let me punch it in the calculator. It's 52.92 minus 73.5, it's minus 20.58 equal to 0. And then we transpose that to that side. It's 0.64 f equal to 20.58, and then we divide both by 0.64, and then your f will be divided by 0.64. The answer is 32.1. Let's say 32.16. That's the force applied. This is the force applied, guys, that is exerted on a system to keep it not moving. Okay, let's go to the next question. The next question, it says the satellite is orbiting around the earth, and the earth exerts a force of magnitude of that 6,346.07 newtons on a satellite. Calculated the height in kilometers. So guys, this is what is really happening. Let me just draw for you what is happening. So this is 2.3. This is universal. 2.3. Here's the earth, right? The earth, and this is the satellite, right? This is the satellite. So the force is exerting, the earth is exerting a force on a satellite, the force that is 6,346.07. So they're exerting a force on each other, that force. Now guys, when they're exerting a force on each other, the distance between them, it starts from center to the center there. But in order to know this distance, we call this distance as what? Is r. But this distance is made up of the, from here to here, we call it, it's a what? It's a radius of the earth. And from here to here, we call it, it's a what? It's a height. It's the height. Always it's a height from the surface of the earth to the satellite. We call that as a height. So in other words, the radius or the distance between them, it's made up of, it's equal to a radius of the earth plus the height, right? So what is the radius of the earth? 6,38 you are given in the data sheet. 6,38 times 10 to the power 6 meters. plus the height, which is the one that we want, right? So this is our radius. Now let's go. So this is what they want. They want from this is what we have. We have the radius plus the height, but we want the height. This is what we want. G, mass of the earth multiplied by the mass of the satellite divided by r square, right? So now we substitute the force. We are given the force between them. It's 6,346,07, and then the universal gravitational. The universal gravitational, there it's a constant. It's going to be 6,67. Let me check it quickly. The universal gravitational, it's it's 6,67, yeah, 6.67 times 10 to the power negative 11 multiplied by the mass of the earth we're given as well. It's 5.98 times 10 to the power 24. It's a constant. And then the mass of the satellite we're given in there it's 650 kilograms. 650. We divide here it comes. Our r, guys, is this, but we need to substitute and we square. So it's going to be 6.38 times 10 to the power 6 plus the height square. Guys, when it comes to this, it's going to be a marathon of math, so we really need to understand our math when it comes to that. So what we're going to do here, okay, what you do, guys, you punch the answer of this in the calculator. It's 650 times 6.67 times 10 to the power negative 11 times 5.98 exponent to the power 24. So the answer in the calculator, it is of this side, let me write it here, it's going to be 2.592629 times 10 to the power 17. You keep that in the calculator, and then you cross multiply this with this and this with this. So it's going to be 6,000. The answer is it's 6,000 here. 6,346,47. Even here, it's 6,346,7. You multiply by this, it's going to be 6.38 times 10 to the power 6 plus h, all that square, and then we divide by 6,346.07 both sides, 6,346.7, and then I'll say answer divide by 6,346.07, and then the answer there, this and this cancel, and then you have that 6.38 times 10 to the power 6 plus h square equal to, the answer for this, it will be 4.085 408.7648 times 10 to the power 13, and then we put the square root in both sides. So the square root of this answer here, it's going to be 6,391,720, 241 683. You keep that in the calculator. So this side you have 6.38 times 10 to the power 6 plus h. And then what you're going to do, you say h is equal to this. Let's say it's an answer minus 6.38 times 10 to the power 6. So your answer here, you minus 6.38 times 10 to the power 6. It's going to be 1000. What is it? 11,720,241. The answer there, it's in meters. It's going to be in meters. So they said your answer, it should be in kilometers. So what are you going to do? You're going to times by 1000 there. It's going to be your height. It's going to be 11. You're not timesing, you're dividing. You divide by 1000. So it's going to be 11,72 kilometers. That's